Chemical periodicity is the trends and properties of elements that are based upon the position of that element in the periodic table. As we said before, the periodic law states that when elements are arranged in order of their increasing atomic number, then elements with similar chemical properties end up in the same families or same groups, as we said before, which basically means that that depending on the position of the element in the periodic table, there are certain properties that we can predict. If not the exact properties, then we can at least predict the trends in those properties, the changes in those properties that we can expect. Now, in this class, we will not go into the details of chemical periodicity. We will not be able to go into hows and whys. That is something that you will cover in your later chemistry classes. And in fact, in this class, we will only look at two properties and talk about what changes you can expect based upon the position of an element in the periodic table. The first one of those is the atomic size, or the radius, or the diameter, whatever term you want to use. You may remember from a previous session we said that it is the number and arrangement of electrons that affect the size of an atom. The number of protons and neutrons do not affect the size because the nucleus is very small within an atom. The space, the volume, the size, the diameter of the atom really depends only on the electrons. But it is not just the number of electrons, also the arrangement of those electrons. So if you look at, let's say, a group of elements, let's focus on group 1A, starts with hydrogen, number of electrons 1. Lithium has 3 electrons, sodium has 11, potassium has 19, so on and so forth. What would you expect, or how would you expect the size of an atom to change as you go from hydrogen to lithium to sodium to potassium to rubidium and so on within the same group? Exactly. The size of an atom increases as you go down a group. The atom actually gets bigger within one group, within the same column. The atom gets bigger as the number of electrons increases. If you focus on the halogen family, fluorine with 9 electrons is the smallest atom. Chlorine is bigger than that. Bromine is bigger than chlorine. Iodine is bigger than bromine. Again, the size of the atom increases as you go down a group of elements. But things are not as simple if you go across the period. For example, if you look at the first period with hydrogen and helium. Hydrogen has 1 electron, whereas helium has 2 electrons. Intuitively, which atom should be bigger? Yes, intuitively you would think helium is bigger because it has more electrons. But the size of an atom not just depends upon not just the number of electrons, but also depends on the arrangement of those electrons. Now that's something that you will cover later on in your future chemistry classes. But for now, please take my word that the size of an atom actually gets smaller across the period. When you go from left to right in the same period, the atom gets smaller. So helium is actually smaller than hydrogen is. Similarly, if you're comparing between beryllium and nitrogen that are both in period 2, nitrogen is smaller than beryllium, even though nitrogen does have more electrons than beryllium does. If you were comparing, let's say, tin and iodine, iodine will be the smaller atom compared to tin. So once again, please note that the size of an atom increases from top to bottom in a group, but decreases from left to right in a period. The other property that we'll talk about is metallic versus non-metallic character. Now, as I said earlier, metallicity and non-metallicity of an element doesn't just have to do with the shine or conductivity or malleability. It is deeper than that. It has to do with chemical properties of those elements. Now, once again, without going into hows and whys, metallic character of an element echoes the trend in the size of an atom. In other words, as the atom gets bigger, it becomes more metallic. In other words, metallic character increases going down the group. In other words, the atom is getting bigger, it's becoming more metallic. but the metallic character also decreases across the period, because across the period, remember that the atom is actually getting smaller. So the smaller the atom, the less metallic that element would be. Now, metallicity and non-metallicity are opposite of each other. So whichever metal is more metallic, it is less non-metallic, and vice versa, right? So if you're looking at the non-metallicity of an element, then the non-metallicity goes in the opposite direction to that of metallic character. As the atoms get smaller, they become more non-metallic. So a metallic character actually decreases from top to bottom of a group, but increases from left to right of a period. So just to